now we'll be doing about the uses of concave and convex mirrors. Okay. Now concave mirrors and convex mirror, okay, they are used, okay, in our day-to-day life according to our needs. Okay. And some of the uses, okay, are being mentioned, okay, here. First we'll go with concave mirror, how they are used. Okay. Now in torchlight, okay, torches, okay, now you will find that, okay, suppose this is a torch. Now there's a headlight there, okay, and you will find that the portion, okay, is concave. Okay, why did they make that part, okay, concave? Is because they have adjusted that small bulb of light, okay, in the torches in such a way that it is at the principal focus. Okay, imagine, okay, like we have this as the torch, okay, and then they have placed it here, okay, that small bulb of light, and then you will find that inner, okay, it's concave, okay, and they have placed this in such a way that it is at the focus. And what happens is that according to the rule is, when rays of light coming from this bulb, okay, it will strike this and then it will come out as parallel. A strong beam of light coming out from the torches. Okay, so that's why they make that portion concave. Okay, and then another uses is when at the makeup mirror, like especially for girls, and shaving mirror for boys. Okay, now if you use a plain mirror, okay, the size is the same. Okay, so that's why it's not that useful. But if you use a concave mirror, now when it is very near, you will find that what is important is that the size is enlarged, quite enlarged, so you can see very clearly. Okay, so those makeup mirrors and shaving mirrors, they are made up of concave mirrors because the image is quite enlarged and it will be beneficial according to our needs. Okay. Next we have it is being used by dentists. Okay, when you go, okay, and examine your teeth, the dentist, okay, he will take this mirror, okay, a small one, okay, and then he will place it, okay, inside your mouth now to examine your teeth. Okay, now the reason is because in the mirror, okay, an enlarged image is formed. Okay, so that's why they have used the concave mirror. Okay, and it is also used by doctors also for examining the eyes and the, but usually, okay, by dentists. Okay, and even in automobiles also, okay, it is being used as reflectors. Okay, just like torches. Okay, they have made what? Okay, they have placed the beam, right? The beam light, right? And then the part is concave. Okay, so when rays emerging from the beam light, okay, it hits this concave, this reflector, okay, which is concave in nature. Okay, it will, okay, a parallel beam of light will be emerging. Okay, that's why a strong beam of light will be coming out. Okay, then next is the uses of convex mirror. Okay, rear view mirror. Okay, like the side of your vehicle, there's a mirror. Okay, and then they used to write in the rear view mirror. Okay, size is not as, okay, as normal as they are. Okay, like you will find that, okay, like in the rear view mirror they are used because why? To check the back side of the vehicle. Now it's not possible, okay, to do that with the help of your head, okay, by turning. Okay, now you use with the help of a rear view mirror so that, okay, when you want to start, you will know that there is actually no vehicle actually coming from behind. Okay, for your safety, okay, they have placed a rear view mirror. Okay, so and also they have used a convex mirror because a convex mirror, okay, it size is very diminished and it provides a wide field of view. Okay, a wide field of view means that, okay, at a very far distance also the image will be formed in the rear view mirror. Okay, in the rear view mirror. they are placed along roads where there are turns, okay, there are sharp turns, or maybe there are roads, okay, where there are connecting roads, okay. So what you will see that there's a mirror like this, okay. Okay, it's red in color, okay. Okay, it's red in color, and then it's very bulging, okay. That is also a convex mirror. Why they have used that? Now they have used so that the driver can see, okay, whether there's any traffic, okay, coming, okay, to avoid accidents. Okay, so those are the some uses of the concave and convex mirrors. Okay, so there are sign conventions, okay, for reflection by spherical mirrors. So the rules are, the first one is the pole is taken as the origin. Okay, so pole is taken as origin. The second is that the principal axis, okay, is taken as the x-axis. Okay, so I'll take for the case for a concave mirror. This is the pole, so this is it will be it's taken as the origin, and then this is the principal axis, which is the x-axis. So the next rule says that distances are measured from the pole, okay, because it is like the origin, okay. So distances will be measured from here, okay. Just like in the graph, we have origin x-axis, okay. The same thing here also, okay. They will be measured in the same way, but it's just that like in the graph paper, this side will be negative, right, and this side will be positive, okay. So you just remember, left of pole will be negative, right of pole will be positive, okay. So left of pole or left of origin will be negative, and right will be positive, okay. Now the fourth rule says that, okay, it's regarding the height, okay, of the object, okay. The height of the object, okay, if it is erect, okay, it will be positive, okay. So if however it is inverted, okay, it will be negative, okay. So if the perpendicular distance like this, okay, is erect, so it's positive, okay. And the last rule, it says here that the object will always be to the left of the mirror, okay, the left of the pole, okay. So object will always be located on this side. For a convex mirror also, the object will be placed towards the left, okay. Then next, okay, there's this magnification, okay, and certain formulas, okay, to help solve problems. Now magnification, now what is this? It is a ratio of the height of the image to the height of the object, okay, denoted by small letter f, okay. So it is the ratio of the height of the image formed and to the height of the object, and it is also found that magnification is equal to the ratio of the image distance to the object distance, however with a negative sign, okay. So m is equal to hi by h0 minus v by u. Also, this will be required for solving problems, and magnification also tells us, okay, that if m is greater than 1, m is equal to 1 and m is less than 1, what happens, okay. Now if m is greater than 1, we say that hi is greater than ho, means that the image form will be quite big, okay. Just from suppose, okay, you don't see the image form, but they have given only the magnification, okay, with some conclusion. say they have given magnification to be 2, then you can conclude that the size of the image is quite big compared to the object. But M, if it is equal to 1, they are of the same size, the object and the image. That's why for plane mirror, okay, very important, okay, for plane mirror, M, it is equal to +1, okay. And then when M is less than 1, then the size of the object is quite big compared to the image, okay. Also, what can we learn about the magnification? I mean, what can we learn from the magnification is that if M is positive, it is image is virtual and erect, okay. So if you see that magnification is plus, you can conclude directly. But if it is negative, image is real and inverted. Real and inverted. So that's why, okay, magnification gives us this information: the size of the image with respect to the object, and also the image, whether it is in virtual or erect. Okay. And after this, okay, there's this very important formula called the mirror formula. Okay. The mirror formula, which states the relation between the object distance, the image distance, and the focal length of the mirror. Okay? And the relation is this: 1 by V plus 1 by U, it is equal to 1 by F. Okay, so this is the relation. Okay, so now just remember, okay, the sign partition and this formula, and then you can proceed with the numerical problems. Remember, erect, okay, this, if it is erect, positive, inverted, negative, and if it is to the left of the origin, I mean of the pole, it will be negative, and to the right it will be positive. Okay, and for concave mirror you have to know, okay, when it is real, when it is virtual, they will mention, okay, according to the problem. Okay, so you have to read the problem carefully for the case of a concave mirror, because sometimes the image is real and sometimes the image is real and sometimes the image is virtual. So from there the signs also will differ. Okay, so this problem, a converging mirror, also concave mirror is called a converging mirror, convex mirror is called a diverging mirror, and then it forms a 3 times magnified virtual image. Okay, virtual. Okay, virtual. So from ray diagrams, okay, you will see that virtual image, they are formed where? Behind the mirror, right? Okay, here. That is, you have seen that when it is located between F and P, the image is formed here. Okay, and it is virtual, erect, and enlarged. Okay, so you see here, this is the origin, serves as the origin, and image is here. So obviously this is positive. Okay, positive, and I told you object will always be here. So this one will be negative. What will be negative? The object distance. What will be positive? The image distance. Okay, so those conclusions first has to be kept in mind, then you can proceed. Okay, and you know that virtual is always erect, so here also it will be positive. Okay, and then the height also of the object, it is positive, being erect. Okay, now, okay, from the question, okay, given height of object, okay, you first write what it is given to you, then, okay, height of object, okay, let height of image, okay, height of image, they haven't given, okay, it is HI, they have given what? That it forms a 3 times what? The height of the object. Okay, so height of object, and height of object, it is denoted by what? h0. Okay, so hi it is 3 times h0. And what is this 8 centimeter? When an object is placed at a distance of 8 centimeter from it. So it is the object distance, okay, from the mirror. So it is u, and since it is towards the left, okay, of the pole, okay, so it will be negative. Towards the left of the pole, so it will be negative. Okay, and here hi is positive. Why? Because virtual error. Okay, so plus. Okay, so you need to calculate what the position of the image means, the image distance and the focal length. Okay, to solve this one, okay, we use this magnification. They are equal, right? Now what is hi? 3h0, and this is h0. And then what is v? We have to find out, and this is minus a. h0 and h0 cancel, minus and minus cancel. We get v to be 24. Make sure the sign it is positive because why? It is towards the right. Okay, so it's correct. Okay. Then next we have to find the focal length. To find focal length, okay, you have to use what? The mirror formula. Now 1 by v plus 1 by u is equal to 1 by f. Then you substitute what is v? 24. Okay. What is u? Minus 8. And then 1 by f. So from here it will be 1 by 24 minus 1 by 8. This is 1 by f. So after taking LCM, you will get minus 2 by 24. This is 1 by f. So this one will be minus 1 by 12, right? When you flip this to the other side, I mean turn this upside down, you will get f. And you see here, f is negative. Remember, for unknown variables like this v, I haven't given any sign, right? vf, now it will come automatically. Okay, no need to put the sign. Now, in this case, it is clear, right, why it is positive. And for this case, why it is negative? Because you know that focal length is to the left, right, of the pole. So that's why left is negative. So it is hence negative here. Focal length. Okay. Now, for this next problem, okay, it is for convex mirror. Okay. The previous one is for concave mirror, this is for convex mirror. So after reading the question, okay, you note down what is given. Okay. So an object 5 centimeter high. So height of object is what? 5 centimeter. Forms a virtual image because convex always forms a virtual image. So then it is erect as well, so it will be positive 1.25 centimeter. Okay, this is centimeter here. Sorry. And then this object is placed at what? At a distance of 24 centimeter. So this is object distance, and since object is always placed towards the left, so it will be negative. Okay. Then we have to find v and we have to find f. Okay. So we'll find first v with the help of magnification. That is hi by ho is equal to minus v by u. Remember, for v, do not put any sign because it will come by itself. Okay. Now hi it is what? 1.25, and this one it is 5, and then u it is minus 24. So v it is equal to 1.2555 into 24. So you cancel this. Okay, and then 25 minus so you get 6 centimeter. Okay, and you have to calculate the focal length used with the help of the mirror formula. Okay, it is positive y because it is virtual to the right of the pole. Okay, image distance 1 by u minus 24. This one is 6 1 by f, and then here LCM is 24, so this one is minus 1 plus 4, this one is 1 by f. So from there you get 3 by 24, 1 by f, 1 by a, and then f you get to be 8. So, and you see here the sign is positive because for a convex mirror, focal length is towards the right. Okay, so the sign is hence positive, and hence the calculation is correct. Okay, that's all sign. Students, I hope you have understood whatever I have discussed in today's class. You can solve the rest of the problems by yourself. Until then, stay safe.